Yes. All right, guys. All right, guys. Let's focus in on these two here, and you'll have the rest of the time to work on the assignment. All right, guys. So what we're doing here is combining transformations. So we're going to do more than one transformation at a time. Now, we're not going to be applying more than one at a time, but we're going to take it one at a time and continue to apply each one after the other. And the way that we apply them is the order that they appear. So whichever one appears first is going to be the one we do first. So if we look at this problem here, let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation of 3 units up of the graph of f of x equals x. So our first transformation is a vertical shrink by a factor of 0.25, followed by a translation of 3 units up. So we have two different transformations that are happening. And when we do this, we're going to take it one transformation at a time. Questions on this so far? Now we need a way or a letter to name the first transformation that we applied to it, because G will be the one that we use for applying the last one. So someone just give me a letter. T. So we'll say T of x is equal to. So since we're doing a vertical shrink by a factor of 0.25, we're going to use the general form A times our f of x. And we use f of x because we're applying it to the function f of x. Now, A is our amount that we are stretching or shrinking the graph by. So our A, our amount that we're applying to it, is going to be 0.25. And we can go on and replace the A value with 0.25. Now, since we still have f of x, we can replace it with its function, what it's equal to. And what is f of x equal to? Because f of x is equal to x. Because our 3 units up is our next transformation, what we're going to do next. Almost. We do have to multiply the 0.25 in x. So 0.25 x. And that's our first transformation. We have the vertical shrink by a factor of 0.25. Done. And really up to this point, it hasn't changed. This is exactly what we did yesterday and Friday. So that's not any different. But what is different is now we're going to apply another transformation to it. And since it is our last transformation, we'll call this next one g of x. So our next translation is what? 3 units up. So the general form, we would normally say that this is f of x plus k going up and down. But we're not applying to this to the function f of x. We're applying it to what? T of x. Because we're applying it, we used one transformation for T of x. Now we're going to apply this next one to T of x. Because we used f of x in all our general forms because we were applying that transformation to f of x. Now we're applying this next one to T of x. And again, f of x, T of x, it's just a way to name the function. Now our value of k for this here is 3 units up, so k would be 3. Now would it be positive or negative? Positive because we're going up. So we replace k with its value of plus 3. So now we are, since we plugged that in, we'll plug in our t of x, or we'll technically we're replacing every x in t of x with x, which really doesn't do anything. We're just replacing it with what it's equal to. So 0.25x plus 3. Now, since there's not a number in front of our parentheses, just drop the parentheses, telling us that g of x is equal to 0.25x plus 3. Questions on this here? We feel good with this here. Because for the most part, these combination of transformations isn't any different than what we did. We're just taking it one transformation at a time. Yep. Let's look at this one here. Let the graph of G be a translation 6 units down, followed by a reflection in the x-axis. So our first transformation here is 6 units down. Our second one is a reflection in the x-axis. Levi, give me a letter.
Q.
Our first one, we're going to call it Q of x. Doesn't really matter what we call it. And really, in the end, if you call it G of x or H of x, I'm just going to be looking more at did you apply the function, the transformations correctly, not so much your letters or how you named it. Now, our translation of 6 units down is being applied to f of x. So our vertical translation would be the function we're applying it to, in this case f of x, plus our k. Now our k value is going to be the amount that we move it up or down, which is 6. But would it be positive or negative?
It'd be positive. Negative.
It would be negative since we're going down. So q of x would be equal to f of x. We can put plus negative 6, or we can just say minus 6.
Congratulations. Someone poured up freaking stinks. Is that what you watched? Yes. By the way, dude, I drank 2 and 4. I'm eating water. Straight 2. Yellow out.
All right.
That's good. Great, great. I know it's good, but like.
All right, guys.
What?
All right, guys, let's focus in here. So the next thing we need to do is dealing with our f of x. Now, since it is still f of x, we can replace it with what it's equal to is
Radical x. All right, absolutely.
the absolute value of x.
Since we can't do anything, it's an absolute value.
Since there's nothing in front of the parentheses with our absolute value of x, it's just going to be absolute value of x minus 6.
No, we have to do it again.
So our translation of 6 units down is done. We want to follow that up by a reflection in the x-axis. So the general form for reflection in the x-axis is negative f of x. But we're not applying it to f of x anymore. This time we're applying it to q of x. So we would say that g of x is equal to negative q of x. Again, f of x, g of x, they're just different ways to name these functions. And with this one here, we're wanting to reference this one here. Now at this point here, we can replace q of x with its function, which would be the absolute value of x minus 6. At this point here, we're going to distribute the negative through. Now the negative can't go inside the absolute values. We just put it out front. So that'd be negative absolute value of x. And our negative 6 would make it Positive 6. Because two negatives make them positive.
Does that mean two wrongs make a right?
Yes, it does.
See, that's what I've always thought about.
That means every.
If I murder one person, it's wrong. If I murder the second time, it's alright, right?
No, it means if they murder someone first, then.
What if
No,
every bites
if
my
I
finger?
murder two people and it's okay.
What if every bites off my finger?
No,
I
because
just thought I
two
was.
wrongs make a right. Not two wrongs don't make a right.
They might shut up.
You shut up, David.
He's really thinking about it.
Where did we go wrong?
Me?
Skippy toilets. That's
Yeah.
What? What are you talking about?
Any questions on this here?
Squirrels great.
Yeah, negative. Oh, all good.
I'll do the math tonight.
Wait, what?
Yes, I will.
I slumped tonight.
No, I gotta use.
All right, guys, you have the rest of the hour to work on this here.